Insects, whose lifestyles have been thoroughly studied, leave scientists guessing about their homosexual behavior. This is one interpretation. The female parasitic wasp is ready to mate. Her irresistible perfume is designed to attract all available males. One male dances for all he's worth, hoping to gain her consent. Another female and another male. So far, everyone's playing by the rules. But this male is getting too carried away on the dance floor. Just as the female signals her admiration, another male rushes in and claims the reward. The original suitor arrives to collect his rightful prize. Flushed with success, he doesn't notice that he's trying to mate with a male. He doesn't realize because the second male, after contact with the female, now smells like her. The first male makes increasingly frenzied attempts to copulate and wastes precious time doing so. Sandwiched in the middle, the second male has one more trick to play. Once the female leaves, there's a danger her original suitor might follow her. He must be detained as long as possible. The second male drops his antennae just like a female. The ruse works. The hapless loser tries again. So could homosexual behavior occur simply because a rival has been duped? It may be true for this wasp, but it doesn't explain the variety of homosexual behavior in nature. And if this behavior persists, reappearing generation after generation, then it must, so the argument goes, have a genetic basis. To study this question, scientists turn to the fruit fly, the creature whose genetic structure they know better than any other. In the wild, about 8% of these flies show some homosexual behavior. In the laboratory, a team of researchers led by geneticist Jean-François Ferveur is attempting to find a genetic marker for this behavior.
When we observe the behavior of this small fly, we find that it's extremely sophisticated. Its tiny size may make it seem unimportant, but that's simply not so, because it has the same biological functions as any vertebrate or human being.
Sophisticated though this fly is, the team has managed to modify its behavior and artificially increase the rate of homosexual behavior to 90%.
To produce these generations of flies, we inject a fragment of DNA into an embryo, thus modifying the fly's genome. And so artificially we reproduce homosexual behavior.
The male with the red eyes has been genetically modified. He's trying to court the white-eyed, unmodified male. The red-eyed fly licks the other's genitals. But White Eyes scorns these advances and makes a show of cleaning himself up. Red Eyes doesn't seem to notice that he's been rejected and tries again. Ferveur believes that rather than actively seeking male company, this modified fly can no longer tell the difference between males and females. So instead of finding a genetic marker for homosexual behavior, the scientists may have simply removed the male's ability to discriminate. When several modified males are put together, something extraordinary happens. They all attempt to copulate with the male in front, creating a chain of dancing males. So does this artificially produced behavior suggest that there might be a gene for homosexuality in humans?
I think if you want to simplify or compare an organism such as a fly to humans, then the only comparison you can make is that a fly itself is already complicated enough. So in humans, to simplify certain behavior to one gene or even a series of genes, I think we're still a long way off.